Thank you. Thank you. Thank you all for being here today and joining me at this session about continuous integration and continuous delivery with the Thinkwise platform. Well, to start off this presentation, I really want to focus on why we chose this subject, why this is important. Even in the enterprise software development world, we see that an agile methodology is adopted. Instead of building applications, big bang, releasing applications, big bang, releasing only one big version per year, we see that even the enterprise applications are switching to smaller release cycles instead of big bangs released only once. Now, this has a lot of advantages using a short release cycle. First and foremost, you get feedback really quick from your end users. If you release some new features, you can collect feedback on them, iterate upon that, maybe even prioritize it over developments that you had planned to make that feature fit your business better. So you really get some tight feedback loops. But maybe even more importantly, you have a very short time to value. Software development costs money. And if you get the benefits of that quicker, you can. It's way more interesting to develop software than if you have to invest a lot before you can see the results. So a short development cycle, a short release cycle, is really beneficial in your time to value. And a thing that's often overlooked is fast recovery. If you release a very, very big application or a very big release and there is something wrong with it, especially when it's an update, it might be quite difficult to trace an issue. If there's regression within that release, if something changed in that release that breaks down, you have to go through all of the things that you changed to pinpoint that specific problem. However, if you run a very short release cycle, you can pinpoint that way more accurately. You know exactly what you changed in this release. So this helps with some quality improvements, fast recovery if anything goes wrong. However, there are definitely drawbacks in an agile approach, in a short release cycle approach. Now, today's session is not about comparing different software development methodologies, but there is one drawback that we can do something about, and that is the overhead for releasing a new version of the application. You have to develop the application, then you have to get all those developments that you have done for that release together. You have to check the changes for quality. You have to run your tests on it. You have to bring it to the different environments, to deploy it there, to test it there. And there's some serious overhead that might be associated with that, especially when the applications become larger. So how can we deal with that? Continuous integration and continuous delivery focuses on automating these kinds of processes. And it basically consists of four different steps that I would like to talk about today. The first one is integration. Now, this is a different kind of integration from the previous session. I know Marjolein also talked about integration, but that's integration of different applications with one another. This kind of integration is integrating the changes you did into your development environment. Making sure that all the changes that have been done by the various users are actually merged together into a single product. Second one is testing. And of course, there's always room for manual testing, but there's a lot of test automation being done as well, and quality assurance being done as well. That you can run on a test environment or run on your development environment if you choose to do so. So once we've done all this, we have a proper application, and we can then take this application to a different environment, a production environment, a test environment. And this is what the D in CI/CD stands for. Now it's a bit ambiguous. Because sometimes people refer to continuous deployment, sometimes people refer to continuous delivery, and they are a little bit different, but I'll discuss both of them today, because both of them are really important when it comes to application development lifecycle. So this is basically the agenda for today. We will talk about integration and testing in the second part. We'll talk about deployment and delivery in the third part. And we will approach this as if they are manual processes. And in the last part, I will focus on automating these processes. I'll use delivery as an example, because we don't have time to go through all of it. But this is also the most complex of these scenarios. But before we get into that, I want to recap a little bit about the Thinkwise environment. I'm not sure if everyone in the audience is familiar with the Thinkwise platform, with the architecture of the Thinkwise platform. So this might be a bit of a recap for some people, and it might be completely new to other people. But I think it's important as a context for the rest of this presentation. So, Thinkwise environments. A typical development, application, test, and production environment. What do they look like when you use the Thinkwise platform? For all the demos that I'll have for you today, I'll use a freshly installed development environment, and I'll use a freshly installed production environment. I'm going to skip the test environment, I'm going to skip the acceptance environment, I'll run my test on development, and I'll pretend that I don't need acceptance. So what do Thinkwise environments look like? Now, on the left side, you can see the development environment, and on the right side, you'll be able to see the production environment. The development environment consists of the Software Factory integrated development environment. And if you really zoom into that, you can see that it consists of several layers. It consists of a database layer that hosts all the information in the development environment, an application tier, to be able to work properly with that application to run all the processes, and a user interface so a developer can actually work with the development environment in a graphical manner. And the production environment looks exactly like that. You have a user interface that an administrator would work with. You have an application tier that exposes all the necessary actions, and the Intelligent Application Manager database. Now, in the production environment, the Intelligent Application Manager is used for authentication processes, authorization processes, user preferences, logging, typical production scenarios, whereas the Software Factory environment is used to develop new applications, to develop new models. So production, more of a management situation, and development, well, a development situation. So once we start developing an application, what would it look like? Oh, before we get to that, this is important. But if you've been at the previous session, my colleague Vincent already might have notified you about this, but it doesn't really matter what kind of hosting situation you are in. So these various components that you see here, the database, the application tier, the user interface, they can be hosted in all kinds of scenarios. You can say you can put them all in containers if you want to. You can host them on premises. You can host them on a Windows server, Linux server. You can put them in platform as a service services by the various cloud vendors, such as Google Cloud Run or Azure Web Apps, or you can use Elastic Beanstalk from Amazon. The components that you see here are not bound to a certain platform. But it's not important for this session. The way that continuous integration and continuous delivery works when it comes to releasing new applications, when it comes to updating existing applications in the environment, is not really affected by the way that the environment itself is deployed. So, what does it look like developing an application in these environments? Now, once a development team or developers start working with the Software Factory, they create a model of the application that they want to release, or even several models if they want to build several applications. This product model is stored in the Software Factory database. And this product model is used to generate a product database. Now, if the product database was already there, it will generate an upgrade script for that database, and it will also provide a data migration path to bring all your data up to date to the latest version. But this is not all that a product model does, because okay, we have a database, but we still don't have a UI. We still don't have an application tier. However, it's important to know that the model describes the UI. It describes how the application tier should expose its services. And instead of having to redeploy an application tier specifically for this application, or redeploy a user interface for this application, the existing application tier in this environment and the existing user interface can pick up on this model, knows about the existence of the product database, and just facilitates the application to the end user, or in this case, to the tester or the developer. So this is very different from a typical approach when it comes to deploying application. You don't need to redeploy a user interface if you perform an update for your application. You don't need to redeploy an application tier. The only thing that you need to do is to get your database up to date. So this is what the product looks like in the development environment. Once we bring this to a production environment, of course, we need to bring the product database to the production environment as well. But without the model, the application tier cannot function. And without the model, the user interface cannot function because it would not be aware of how to represent this backend to the end users. So the product model is synchronized to the intelligent application manager. It's either placed there or it is updated. And at that point, again, the application tier, they load this model, they interpret this model, and at runtime, facilitate services to access the logic, to access the database, to access the data, etc. Now, on top of that, in the production environment, an authorization layer is applied as well to actually limit the amount of services that are offered to the user based on their role-based access control. But the key takeaway from these sheets is that you need to do two things. You need to upgrade your database, and you need to place your model to a production environment. So I hope this gives a bit of an idea. It's rather simplified, but I hope this gives a bit of an idea and a bit of a context for the upcoming slides about how to automate these kinds of processes. So back to the agenda. We've had a bit of a recap about Thinkwise environments, and we'll now look at the integration and the testing part of the agenda. So, like I said, I'm starting off with a completely empty environment. It's a freshly installed software development environment. We actually use our ThinkLab environment for this. You might notice it somewhere in one of the URLs. To start off with, we need some kind of model, and unfortunately, I don't have the time to build an application here for you. So instead, I'll use an application, a sample application from the Think Store, and I'll install that one. I'll download that application to my development environment, and I will run validations as a form of testing on that model. I'll deploy that application to the development environment, and I'll run a unit test to further test the quality of that application. And these are all manual steps. We're not talking about automation just yet. So this is the Software Factory, and at the Software Factory you can find the Think Store under the enrichment section. Well, there's a lot of examples here and integrations here available to you. But I'm going to download a rental application that is available to me here. And I'm going to call it Summit Rental version 1.0. And it will download and install this application to my development environment. Now, this is just a sample application. I'm not going to go too much into detail about what this application actually does. It's just an example for this session. There are a lot more example applications to be found in the Think Store, and also segments of models that you can integrate into your existing models. So be sure to check it out if you haven't already. There's some real value to be added to your existing applications as well. So we have a model now, and now we want well, we've done a lot of changes technically, and we want to integrate this into our development environment, into a product that is running in the development environment. And that consists of several steps. The first step is to generate the definition. Definition generation enriches the model So it checks out the model and it adds segments to the model where necessary. And these can be simple things such as logging, tracing, aspects that you want to apply everywhere. It might automatically translate some of the information that is available to you. It also provides a transformation step from that model to a language-specific model, a model that describes how this should be rolled out, in my case, on a SQL Server database. Because the model is generally platform independent, and the scripts that I will need to roll out on an Azure database, in this case, needs to be platform specific. So that transformation is also done during this step. So once we've generated the definition, and this went really fast, and I might have sped it up a little bit, but the larger the model is, the more this takes time. And this is a step, it needs to be done, but it does take some time, and that's why we want to automate these kinds of things. So after generation, the first quality steps kick in, and that is the validation of the model. Now, those familiar with classical programming languages, you can compare this to a linter. It checks the model. It's like a static model checker. It checks the model for all kinds of inconsistencies, for things that you have to worry about, the things that you have to look into. So the platform is shipped with about 700 or 800 of them, but you can add your own as well to add some governance to the model, or to do some extra checks for data migrations, etc. So that is the validation step, one very important quality step. Now, I don't get any errors here. Oh, I see it's repeating. I don't get any errors here, so I can just skip over them, but I should probably look into those warnings at one point. Ideally, you want this all to be completely green. So next step is generate source code. Now, this will generate the actual physical scripts that I can use to either install a product database or to upgrade an existing product database. Now, for this one, I haven't actually physically stored them. They're still in the Software Factory database, and from the Software Factory database, I go to the next step, which is to execute this code. And this is the step that creates the actual database. So I connect to my development environment. It automatically selects the steps that are required to update the environment. In this case, you have to create the database. And that way, it creates the database. Now, the last step in this, after the database has been created, is to run the unit tests. And the unit tests are part of the model, and they perform typical assert, assemble, act structures on the logic that I have created for my application. For instance, whether or not a number of invoice lines actually sums to the correct number, etc. So this tests the logic that is present within the application. So once these have all run successfully, my application is created, and I can log into it. And I don't need to deploy a user interface or a service layer, so I can log into it, and you can see the application has been built successfully. Apologies for the repeating videos. They should stop, but it is what it is. So this is a manual development rollout. This is the steps that you need to take for integration to get all these changes that you've done in the model onto your final product, and to perform the necessary quality checks that are part of the development cycle, the validation, and the unit tests. Now, I've done them as individual steps right now, but that is not necessary. There is a button there to just run the whole thing at once. And there you can also configure whether or not it should continue with the next step, depending on the outcome of the previous step. For instance, if there are any errors in this case, it would stop the process, because we need to resolve those before we can continue on to source code generation and execution. Now, this activity that you do here to start the whole chain at once is one that I want to look in a little bit further, because the Software Factory itself is a product built with the Software Factory. That means that just like any other product built with the Thinkwise Software Factory, it has an API, and we can use this API to automate certain steps, or to call them headless, so to say, without a user interface. Now, in this case, the whole generation, validation, generate source code, execute source code, and running of unit tests, we call that a complete creation. You can also do that via an API call. In this example, I'll use Insomnia as a client to perform API calls, but you can do this basically any way that you want. So if we go back to our environment, and I have Insomnia opened up here, and I can fill in the parameters that are required. All of the parameters that I have not specified will just use the default values, and I can invoke that. And now it will have started this entire development rollout. So if I open up my deployment screen again, it's not necessary to have the UI open to begin with, but if I open it up, I can keep track of what's going on. And I can see that the generation is running, the validation has already kicked off. And once the validation is done, it will start to generate the source code. And once the source code generation is done, it will roll out these changes. Well, there are no real changes, but it will update the development environment. And you can see it didn't try to recreate the database because it already existed. So this is a very a simple way to completely automate this process. With a simple click. Now, if you want to do this more fine-grained, you can also call the individual APIs, for instance, to only perform generation. Or if you want to do a nightly validation of your model, you can use that specific API to only run validations or to only run the unit tests. Anything that you can do as a developer manually, you can do via the API. Now, before I could dive into the automation part right now. But I want to focus on some more complex scenarios first. I would like to focus on deployment and delivery before we dive into automation. So we've seen the Thinkwise environments, we've seen integration and testing in the development environment, and I will move on to deployment and delivery. Now, the nuance between those two, the one is releasing an application directly to another environment, deploying it to another environment. And delivery is to create the artifacts that can be used to deploy to another environment, or even to deploy multiple instances of said environment. So deployment to another environment, if you recall the deployment to the Intelligent Application Manager, it requires an extra step. It requires serialization of the model so we can bring that to the Intelligent Application Manager. So the general flow is the same. We generate the definition. We validate the definition just as a check to make sure that the model is still okay. We generate the code and we execute the code directly on the target environment for deployment. And we generate synchronization scripts, and these synchronization scripts are then executed on the target environment, on the Intelligent Application Manager in the target environment. And then we activate the application, and we have our application available to us in our production environment. And like I mentioned before, and it bears repeating, we don't have to deploy a user interface, we don't have to deploy an application tier, because we can just reuse the existing ones. They will pick up on this new model that was pushed to the Intelligent Application Manager. Now, this is not always possible. For a typical test environment, you probably have access from your development environment straight to your testing environment. You can probably connect to it and push the information there, or even have access directly to the database to create the database or update the database. But generally, you don't have access from your development environment straight to your production environment. There's usually some separations of concerns going on there. So delivery to another environment looks a little bit different. So instead of executing all of these steps on the target environment, we create deliverable deployment artifacts. So basically, we generate the definition again, we validate the definition, and at that point, it starts to diverge a little bit. So, of course, we need to create the model that will be placed in the intelligent application manager. So we generate the model synchronization scripts. And we don't know whether or not the target environment is a clean environment or if it's an existing environment that needs to be upgraded. So we can generate both upgrade scripts and installation scripts. So the same package can be used to upgrade existing environments or to install new environments. Now, we need to get these out of the platform. We need to make them portable. So we can deploy these deliverables to some kind of storage. And there's various options here. If you run the whole development environment in an on-premise situation, you would probably write them to disk. That would be easiest. But if you run your development environment in the cloud, it might make more sense to use the storage associated with that cloud. For instance, an Amazon S3 bucket as a target for these scripts, or an Azure storage account where you send these deployment artifacts to. So there are various options here, and you can configure the Software Factory environment to send it to a certain location. Now, there's another element that is added to this, and that is a manifest. And the manifest describes all of these deployments artifacts, and we can use this later by our deployment center. I'll get back to that later. So once we have these various elements available to us, we then still need to do the actual deployment on our production environment. Now, you can do this manually, and feel free to do so if you set up your scripts like that. However, we do have an application available to us that can consume the manifest, and using that manifest, it can basically create a wizard that will help you to install or upgrade an existing environment. Now, if you've used the Software Factory, and if you've used the Intelligent Application Manager before, you probably recognize this one, because we use the same tool to install software factories. We use the same tool to install our development environment. We use the same tool to upgrade our Intelligent Application Manager as well. And like I mentioned before, these are the same. These are Thinkwise applications. So you can use this tool using the manifest that has been generated to install or upgrade your own applications as well. So once it consumes this manifest, you can use it to connect using different credentials or even a completely different environment, connect it to that environment, execute the install or upgrade scripts. The deployer will help you with that. It will synchronize the model to the Intelligent Application Manager, and it will then activate the application in the Intelligent Application Manager. I hope this gives a bit of an idea what deploying to another environment and how delivering artifacts to another environment, the nuance between those two, how that affects the way that you approach these things. Now, a user interface like this, a wizard is not going to help you in automation unless you want to bring in some really heavyweight software to click on these buttons for you. So as an alternative to the Thinkwise Deployment Center, you can also use the command line interface. The command line interface, it's shipped with the Thinkwise Deployment Center. You have two executables available to you, a user interface version and a command line interface version. And you can use that to execute a command that will perform all of these steps for you. You can tell it where it can find the Intelligent Application Manager, how it should connect to it, where to find the manifest, and whether or not to install or update or self-detect whether or not it should install or update. And with a single command, you can update or install your target environment. Now, this one can actually be integrated into something like a PowerShell script or some kind of automation tool. So this is what we'll use as well in the upcoming example. So we've seen the deployment directly to another environment. I haven't really shown an example of it in the user interface, but it's just an extra step to generate scripts and synchronize them to the Intelligent Application Manager. We've seen what delivery looks like in broad stripes, and now we'll move on to the automation of this. Now, the automation will use the delivery as an example. So we are going to create deliverable artifacts and deploy these on a target environment. We need something or someone to kick this off. We need someone to orchestrate this, to execute all of these steps in the right order. And fortunately, there are a lot of tools available to us. So what we need to do is we need to interact with the development environment. We need to tell it, start generating one of these deployment packages of this version for me. We need to get those deliverables to the right location where we can actually use them to run the deployment center. And then we actually need to start the deployment center CLI to perform this action on the target environment. There are a lot of options available to you. We'll use Azure pipelines in this example as a way to orchestrate this process. Now, for those not familiar with Azure pipelines, it's a part of Azure DevOps, and it allows you to provision an agent that performs some of these steps for you. And these steps can be configured completely by yourself. Now, I've given it an attempt to do this. Now, I'm not a DevOps engineer, but even someone like me can automate something like this. However, when you really want to use this in a production environment, I would definitely advise to get a DevOps engineer on board who's familiar with this tooling, who can do this in a secure way, because there's some secret management involved. You can't just connect to a certain environment. And that can also create it in a robust way. So you can, for instance, roll back if need be. If something goes wrong, you don't want your production environment to be in a bad state. But I've created a simple version that allows me to perform all the steps that I showed earlier on the target environment. So I used Azure pipelines, I use a curl script to call some of these APIs, I use some PowerShell, and I use a deployment center CLI. So, so let's look at this pipeline. So this is what Azure DevOps looks like. I've created a pipeline, and this pipeline consists of several steps. I've told it to run every night. Every night I want to update my production environment. First, it starts off calling the Software Factory to generate a deployment package. Now, this is going to take a while. So then I call a second API to wait for this to be done. Now, once this is done, I use the Azure CLI to download the deployment artifacts from Azure Storage. And once this is done, I call the deployment center to deploy these to the target environment. So let's see what this looks like. We're going to hit the run button. And it will kick off this job. And first it will provision an agent for me. And it will download the script that it needs to execute all of these steps. It downloads the deployer, for instance. And it starts the deployment package, and now it waits for the deployment package. Now, I opened up Azure Storage here, my Azure Storage, and it's empty, but if I refresh a couple of times, you can see the application starts to appear. We see an install script appear. If I refresh another time, we'll see the meta model, the model synchronization script, and we see a manifest. So once this is all done, it uses the Azure CLI to download it. Now, currently, in my target environment, there are no applications. It's completely empty. This is the Intelligent Application Manager. But once the deployer starts running, you can see an application appear in the Intelligent Application Manager. Now, I've configured this to automatically give access to me as an end user to that application. So as soon as this is done, we can refresh our user interface. It doesn't need to redeploy a user interface. It doesn't need to redeploy a service tier. And we have our application available to us. So this is how easy it can be to automate this process completely. This is done every midnight. I don't need to touch anything, and it will update my production environment here. I've used Azure DevOps, but there are a lot of options. Paid options, free, open source options to orchestrate these processes for you. So, recap. Every manual action that you do in the platform, not just application development, but also the processes around application development, can be done, can be invoked using the API. I haven't even touched on branching and merging, but that's also included here. The APIs can be used by CI/CD tooling of your choice to automate this process. If your DevOps engineer is familiar with Jenkins, stick with Jenkins. And the Deployment Center CLI is available to you. You can download it. It comes with every installation package of the Software Factory to help you deploy these deliverables in a target production environment. Or even, if you have 20, 30 production environments, it's even more valuable to approach it this way. It would save even more time. So all I can ask you today is to set up these pipelines. Well, not today, tomorrow. To set up your CI/CD pipelines tomorrow to get more quality, to get less manual work in your development processes, to get more quality out of that, to get a more secure rollout process because no user is involved, to get a higher time to value, to really get those releases going, and all in all, to create efficiency, not just within your application development, but also within your application rollout process. Thank you very much for your attention. We do have, I hope we do have room for a Q&A, 5 minutes. So if there are any questions, feel free to toss the cube around. There's a question in the back there, behind the cameras. Good luck.
Hi. I've got one question. When you generate the code, and especially the scripts for the database, do you need to know which version of the database or of your application running? So how do you deal with schema changes in your database?
Yeah, well, that's an excellent question, yes. Before you generate an upgrade script, you can configure the version of the target database. And once you do this, the Software Factory will also help you with setting up a data migration script for the schema changes. And the validations even will help you with that further. For instance, when you add a new mandatory field and it doesn't have a default value, the upgrade's never going to work. So the validations pick up on that as well. It might be interesting to know that in the upcoming version of the Thinkwise platform, the connecting to an existing environment to detect the existing version will be added to that multi-step full creation screen as well. So currently you provide it with the current version, but soon it will automatically detect the current version of the database.
You are able to include your own migration scripts or
That's correct. Yeah, not all migration scripts can be declared. Can be just simple, field A to field B or table A to table B. Sometimes you do have to do pretty complex transformations. So the Software Factory allows you to add custom scripts to various parts of this process, either before the process starts or during the process when you have both the old tables available to you and the new tables available to you, as well as all the way at the end to add some custom manual scripts to guide this data migration process. Yes?
Thank you.
There's a question at the center there. Good luck.
Does that work? Yep. Is there any form of inbuilt error handling, or is that something we'll need to think of ourselves?
And what kind of error handling are you talking about? During a rollout or?
During an upgrade, for example.
Well, yeah, there will definitely be okay, so if this happens during the deployment to production using the CLI will result in an error code if anything goes wrong. And it will be up to the orchestration to deal with that in some way, shape, or form. For instance, reverting to an earlier version of the database or something like that. When it comes to the integration part, if there's any errors during integration, it will, you can configure what it should do. We can either ignore it and just skip it and we'll deal with it later, or you can prompt a user to deal with the problem and just halt the process, or you can just abort the process during the rollout.
Great. Thank you.
Is there also a way during upgrading and you're migrating your data to temporarily block the users?
Yes. So the way that you would do that is you would probably disable access to the application using the Intelligent Application Manager. So that would be typically one of the things that you would set up in your pipeline. Is the first step you do is you block access to the application during the upgrade. An alternative way to go about this is some kind of, some kind of blue-green scenario, but that brings its own complexities. The easiest way to go about it is to disable the application in the Intelligent Application Manager until the process is finished.
And it actively blocks the existing users who are working at the moment with the application?
I think it takes up to a minute before it blocks the users in the existing application. The environment needs to pick up on the fact that the application is no longer accessible. And I think generally that takes up to a minute, but if not, please let me know, because it should take only a minute.
Okay, thank you.
How can we handle hot fixes and user interface upgrades in the pipeline?
That's an excellent question. So today I've only looked at deploying applications. I've not looked at deploying the user interface itself, because it comes with new versions every 3 weeks that you may or may not want to install. Same with the application tier. The Deployment Center CLI can also deploy user interfaces. It can also deploy the application tier, but it really depends on your environment how these actions should be performed. For instance, if you're using containers, it's a completely different mechanism in which you upgrade these runtime components. So it's an excellent question, but it would take me an entire session to fully answer that. Now, when it comes to hotfixes, the deployer has a mechanism to include hotfixes as well. So you don't have to deploy a full application. You can create, it's not something that is available from the development environment, but in your deliverables, you can create a folder next to your install and model folder. You can create a hotfix folder that you can use to have the deployment CLI automatically install the necessary hotfixes. This is also used by the platform itself. The Software Factory has hotfixes from time to time, and it uses the deployment user interface as well to deploy these to the Software Factory environments and the Intelligent Application Manager environments. So the CLI, the Deployment Center has features available to apply hotfixes to existing products without having to go through the whole upgrade process. Oh.
All right, thank you.
Okay, thank you. My name is Len van Toor from Avenue Code. I have a question about the testing. Well, Thinkwise generates code, and there are unit tests going on. Is that still necessary while you generate code and you check all kind of logic and etc. online or real time?
Yeah, there's well, there are a lot of things that you don't have to write unit tests for, so that's the upside. However, there is still logic that and it's more like business logic, business rules and business constraints that you might want to verify using a unit test. For instance, if you have certain calculations within your platform, complex calculations for available stock for certain articles, etc. These are not, even though they are built with the platform, they can still be wrong. So they compile, they work, they do their job, but they give the wrong output. And that's where those unit tests are for. They are for very specific types of logic that a developer creates that they want to validate that way.
Thank you.
Twan Munster, Achmea. I have a question about the peer-to-peer review process. In Azure DevOps, we use pull requests.
Yep.
Is there something like that in your platform as well?
Yeah, so when it comes to code for certain logic concepts, the things that you would also unit test, there's a whole review process there. When it comes to model changes, not so much. We are looking into having the merge sessions, which is kind of equivalent to a pull request in Azure DevOps, to have those more reviewable and to actually be able to add comments to those, etc. It would be great to integrate something like that. Yeah, currently models don't have a formal review process where you can leave notes, etc. But it would be great to add. We have a beautiful community, a Thinkwise community with an ideation section. Be sure to add that one, because I think it would get a lot of votes from the community as well. Yeah.
Okay, thank you.
It will get there.
Laatste vraag, Anne. Anne.
Adi from MyCard. I have 3 questions. First, what are you using in your own development environment? Second, you mentioned about generating the migration or conversion of the database, how you treat rollbacks in case of trouble. That can be tricky. And third, how you handle end-to-end regression tests. So you said the small iterations, you change maybe one little thing, but it may cause issues in different area and application.
Yeah. All right. Okay, first question, what do we use ourselves? Well, the Software Factory is built with the Software Factory. So we automated that as much as possible. We use Azure DevOps for that. So that's also why I was able to make an example like this pretty quick, because we're kind of familiar with it. Back in the day, we used to use Jenkins, but we've moved a lot of our source code for the runtime components, which are classically built, to Azure DevOps as well. So we have the automation of this in Azure DevOps as well. When it comes to rollbacks, when something goes wrong during a schema migration, this is something that you would have to keep in mind when you set a pipeline like this. Currently, in our development environment, we advise people to create a backup of their database before running a schema upgrade. It's not something the platform does for you by default. It's developers' discretion whether or not they want to do that. And if you set this up for a rollout to production, this is something you would have to integrate in your pipeline as well. Now keep in mind that it might be very different on how to approach these things depending on the type of database that you use. If you use an on-premises database, you might have nightly backups or whatever. And if you use a database as a service from a cloud vendor, it might have integrated backup mechanisms. So it's not something that a platform does for you, but it's something that most database management systems have the features for to support. Last question was about the end-to-end testing. We perform end-to-end tests for the platform itself, for the various components of the platform with our development teams for these various components. When it comes to the application itself, we have a manual test scenario module within the platform where you can just write out the regression test that you want to be executed by developers or by testers, really. You can also run the unit tests as regression test if the regression occurred due to logic errors, basically. But when it comes to basic acceptance kind of testing or manual testing, test scripts can be written out in the Software Factory to help guarantee a certain amount of quality and to prevent any regression.
Thank you.
Thanks, Anne.
And with that, I think we are out of questions. Thank you very much.